Hi everybody and welcome to this video on how we evaluate data in psychology. This is part of the Stage 2 Psychology course in terms of Science Inquiry Skills or SIS. Let's get started. So when we evaluate data in psychology, it's very important that we get both valid and reliable results. So an important goal in psychology is to obtain results that are both valid and reliable. These are very important terms that you need to know for not only your design deconstruct and your completion prac, but also any tests or an exam. They have the right to ask you about these concepts, and they often do. So they're very, very important to know. So when we do research in psychology, we need to determine if our results or our data is high in validity, which is the same as accuracy, and if they've got high reliability. So they're going to be consistent if we repeat the experiment or the investigation several times. We also need to determine if the sample size is big enough to represent the population in question. So I'm going to go through all of these terms in more detail. So let's first talk about validity. So the general definition of validity is the degree to which a research study has produced results that accurately measure what it is claimed to measure. So in other words, are we getting accurate results? If we are, that means that they are valid results. So an example, measuring your reaction time with a faulty stopwatch would equal obviously low validity or low accuracy, as it's not an accurate measure of reaction time because we're using faulty apparatus. So it's important that our results are valid or has high or at least moderate validity where possible. Now, there's also other types of validity. There is external validity, so the extent to which the results found can be generalized to an entire population, and ecological validity. So this is the extent to which the results can be generalized to other situations or settings. So external and ecological are very, very similar, but the main difference between them is that external validity is applied to the people or population, whereas ecological, it can be generalized or applied to situations or settings. So this is the people, this is the place, in other words. So in my previous video, I talked about research designs and how it can be very tricky to obtain external validity and ecological validity using experimental designs. It can be very, very hard because the results that we get in a lab or a controlled setting often do not apply in an experimental setting to an entire population because it's too controlled, it's unrealistic, and therefore it would reduce the ecological validity. So it wouldn't apply to real world settings or situations either. So experimental designs typically warrant low external validity and low ecological validity. Not always, but in most cases. So that's often why we will consider as well to use observational designs, because it may increase external and ecological validity, but it may reduce internal validity because, you know, there's more we're more susceptible, obviously, to extraneous variables that impact the internal validity, but it may be more realistic. So it may be more externally valid and ecologically valid, but not internally valid. So there's different ways, in other words, that validity can be impacted at Year 12 level. So it's not just straight internal validity like we learned in Year 11. We need to look at the external and the ecological as well. Now, reliability is the extent to which an experiment yields the same results on repeated trials. So the degree of stability exhibited when a measure is repeated under identical conditions. So what this means is when we repeat our investigation or our experiment several times, are we going to get the same or similar or consistent results? So, for example, measuring height with a ruler and then double checking it, we should get the same result. So that means that that simple measure would have high reliability because our results should be the same or very similar at least. So think of it this way. If you have a reliable car, that means it performs the same way on each occasion. So it starts up, it gets you to school, it gets you to work, it gets you to training, whatever the case may be, it performs the same way and it has the same results each time it's used. So therefore we say it's reliable because it's consistent. Whereas an unreliable car may or may not work depending on the day. So it might, have problems, or, it might blow up, or there might be wiring issues, etc. So an unreliable car obviously won't perform consistently. So it may, make you late, or it may make you miss a shift, or whatever the case may be. So when our cars don't perform in the same way, we say that they're unreliable. The same concept can be applied to reliability of data. So what we want is our results to be consistent. If they're inconsistent, it means they're not reliable and we can't apply them to a wider population. So a measure can be reliable without being valid, but a measure cannot be valid unless it's reliable. So what this means is that we can get consistently wrong results. All right, so we can get consistent results, but they're not entirely valid. But a measure cannot be valid or accurate unless it shows high reliability. So the biggest threat to validity and reliability are extraneous variables, which I've talked about in my previous video. There's many different types, as we've already seen. So good researchers will try and eliminate and/or control these as much as possible. It's usually impossible to control every single one, but try to eliminate as many as ethically and scientifically possible before actually starting the research. So researchers will often sit with their team and talk and list all of the potential extraneous variables before they get started and try and control them and eliminate them as much as possible. There's no good in doing that after the fact because the results are already ruined. Okay, so you should do that before the process takes place. Now, the researcher making impossible conclusions and not giving accurate instruction can also lead to lowered validity and reliability. So if the researcher wasn't clear in their instructions and people just kind of did their own thing, then that's obviously going to lead to inaccuracies and inconsistencies. Also, the researcher making impossible conclusions, like applying, one focus group or one experiment to the whole population, or, making impossible conclusions based on variables that are actually not accurate. So, in line with that, we need to look at the sample and the population. So the sample is the subsection or smaller group of research participants selected from a larger group of interest called the population. So the sample is actually who we do the experiment on or who we use as part of our experiment. The population is the entire group of interest from which the sample is drawn. So for example, a researcher is interested in television ratings in Adelaide. The population would be all people with televisions who live in Adelaide, but the sample would be the actual participants within the research. Now, there are different types of samples that we need to talk about at Year 12 level. So there is convenience sampling. So selecting the sample from a group of people the researcher has access to. So for example, very common, obviously, a high school teacher choosing a sample from their own classes. It's very convenient because the participants are just there, but usually contains a range of bias. So yes, we can get samples through convenience, but usually there's issues in terms of the representativeness and obviously bias as well because of age and geographical location as well. The ideal solution would be random sampling. All right, so every member of the targeted population has equal chance of being selected. This is, again, more desirable because it increases representativeness and it involves selecting names at random. So the more random and the more random the sample, the more likely it is that it's going to be less biased and the groups are going to be more equivalent, which is good. So random sampling where possible is the ideal option because it reduces a lot of those participant variables that cause inaccuracies in validity and reliability as well, or it not being consistent. We also have stratified sampling. So this breaks down the target population into smaller groups. Then random samples are chosen from the smaller groups. So for example, if I've got a sample from a school, obviously we can then break that down into smaller groups. So select then from males and females. I then select from certain year levels, different cultural backgrounds, etc. All right, so the target population is basically broken down into even smaller groups. That is stratified sampling. So the ideal is random, but commonly convenience and stratified are used because the participants are there and it's less time consuming. So speaking of sample size, it's important to consider whether the sample size is big enough to draw conclusions from. So if I only use 30 participants for attitudes towards migration in society, that is nowhere near enough to represent the population in question. I would need to repeat it several times with several more participants, so thousands of participants in order for it to be representative. So the more participants in a study, the more data can be collected and therefore the more consistent conclusions can be drawn that it is representative of that population. So we always want big sample sizes in psychology, always. Speaking of representativeness, all right, the two go hand in hand. So it's important that participants represent the whole population in question. So our sample represents the population. So again, looking at this example, studying society's attitudes towards migration, which would be more representative, A or B? So using all females between 20 and 40, or using both genders equally aged between 18 to 75. Obviously, B is going to be far more representative. So both genders are represented equally and fairly, and we've got much more of an age range, whereas option A, it's very biased and it's not representative of the population at all. So there's no male representation, which is unfair, and it's a very narrow age bracket. All right, and migration, obviously, because of, you know, us living in Australia, we would need a much broader age range because it's obviously been happening for years and years, and, you know, the different rates of migration that have occurred over, several years in Australia. So just using 20 to 40-year-olds is just useless. It's not going to really give us a lot of information. Okay, so that finishes the Evaluating Data in Psychology revision video. As always, if you've got any questions, let me know.